Azure Machine Learning Studio for the non-data scientist. I'm Michael Washington. You can order my book, Azure Machine Learning Studio for the non-data scientist, on aihelpwebsite.com. For our agenda today, we'll first cover what is Azure Machine Learning Studio and how much it costs. We'll then demonstrate creating an end-to-end sample. We'll set it up, get it started, and create an experiment. We'll first explore the data, and using a simple R script, we'll transform the data. We'll then pick an algorithm, and we'll show you how to find a chart to use to pick an algorithm so that we can then train the model, score the model, and evaluate the model. Finally, we'll create a web service. Next, we will operationalize the experiment by creating and consuming the web service using an Excel plugin. Next, we'll consume the web service using an ASP.NET website. Finally, we'll retrain the model with new data to improve the predictive results. First, what is Azure Machine Learning Studio? Microsoft defines it as a fully managed cloud service that enables you to easily build, deploy, and share predictive analytics solutions. If that doesn't make sense, don't worry, we'll cover it more in this presentation. First, let's cover the cost. You'll notice in the middle of this chart that there's a free tier that limits you to 100 modules per experiment with a max experiment duration of 1 hour per experiment. The standard tier, however, costs $9.99 per month with an additional $1 per studio experimentation hour. Your real cost, however, will be with the web service calls. In this chart, it shows the standard web service tiers where the dev test provides 1,000 transactions per month, and the standard S1 tier at $100 per month providing 100,000 transactions per month. To give you an idea of what your cost would be, if you had an experiment that had 500 items that you used to train the experiment, when you train the experiment, you'll have to make a transaction call, so that would be 500 transactions. So as you can imagine, the dev test really will not work if you actually have a real experiment that you're going to use, say, in production. So therefore you would need the standard tier or higher, which would be $100 per month. However, there's another option shown in this chart, which is the classic version of web services. The cost for a classic version of web services would be 50 cents per 1,000 transactions with an additional $2 per compute hour. This is the method that we'll demonstrate in this presentation. First, an end-to-end sample. Let's look at setting up and getting started. The first step is to go to Microsoft Azure and create an account or log into your existing account. You'll then select New, search for Machine Learning, and select Machine Learning Workspace. You'll fill out the form to create a Machine Learning Workspace, and then you'll search for that workspace, select Overview, and there'll be a link to launch the Machine Learning Studio. This will take you to the Azure Machine Learning Studio website, where you'll then log in, select the workspace that you created, and now you're ready to create your first experiment. To create an experiment, you'll select Experiments on the menu and select New. You can select an existing template to start with, however, we will select Blank Experiment. The first step is to click on the title there to rename your experiment to what you desire, and we're going to be using sample data, so we'll select the saved data sets, and we'll select the automobile price data. We'll then drag and drop that to the workspace, and at the bottom there we can click the Save button periodically to save our work. The automobile price data module will display on the workspace, and we can click the little round button. Actually, we'll right click on that and select Visualize. This will actually show us the data. If we scroll all the way to the right, we will see the price column. We can select that price column and then we can select the Compare To drop-down to compare the price to any other column. For example, we're looking at the number of cylinders compared to price. You'll see the candlestick chart at the bottom shows that there actually is a relationship between the number of cylinders and the price. This indicates that that column will be useful in our predictive results. So we'll look through all the other columns and we'll determine which ones will be useful. Next, we'll show how you can transform the data. We'll select the Execute R script module, drag and drop it to the workspace. We'll then connect the automobile price data module to the Execute R script module by first clicking on the automobile price data module and dragging and dropping a connector to the Execute R script. This will allow the data to flow from the one module to the other. When we click on the Execute R script module, we can then alter the script that is there. In the video that we'll show later, we'll show how we create a R script that will eliminate any row that has no data for the normalized losses column. We'll then have to click Run to actually populate the data and transform the data in the module so that we can then see the results. After it finishes running, we can then click on the round circle under the Execute R script. Actually, we'll right click on it and we'll visualize the data, and we'll see that the number of rows has been reduced because any row that didn't have data for normalized losses has been eliminated from the results. Now we'll show how we can select only certain columns for our data. For example, earlier we saw that some of the columns are going to be useful to us, but some are not. So we'll first drag and drop a Select Columns in Dataset module to the workspace. We'll go ahead and connect it to the bottom of the Execute R script module, and then we'll click the button to launch the column selector. The column selector comes up, and it allows us to only choose those columns that we feel will be helpful with our predictive analytics. We'll go ahead and click Run, and if we wanted to, we could then visualize those results, which would only include the columns that we selected. So now we're finally ready to create our model, and the first thing we'll do is we'll use a split data module so that we can use some of the data to train the model, but then hold back some of the data to evaluate the model. So you'll see there number 4, 0.7, which is 70% of the data will be used to train the model. The rest of the data will be used, held back, so that we can use that data to evaluate the model. Next, we'll pick an algorithm. So we will then go to the Microsoft Machine Learning Algorithm cheat sheet, which is located at the URL that you see on the slide. That cheat sheet, basically the way it works is you start at the middle there and you determine if you're predicting values or you're predicting categories like a true or false, or students who graduate or not graduate. In our case, we're predicting values. We're trying to predict a price, and we will then choose a regression algorithm. In our case, we're going to choose a fast training linear model, so we're going to choose linear regression. So we'll drag and drop a linear regression module to the workspace. However, the way we connect that to our data is we then drag and drop a train model module also to the workspace, and we connect the linear regression module to the train model module, and part of the split data also to the train model module. Now, the train model module requires you to select a column that you want to actually predict. So we'll click the Launch Column Selector button, and we'll select Price because we're trying to predict a price. We'll then click the Run button, which actually will populate the data and actually train the model. We now need to evaluate and score the model. The first thing we'll do is we'll drag and drop a score model module to the workspace, connect one end to the train model module, and the other end will be to the split data module, where we'll connect it to the data that was held back. We'll then, of course, click Run to actually score the model, and then we can visualize the result, and the result will show us the original actual price, and under scored labels, this is what the model predicted the price to be. So as we scroll through there, we can actually see that they're pretty close. However, we now want to fully evaluate the results. So we then drag and drop an evaluate model module to the workspace, click Run, and then visualize the results. Here, for a linear regression model, the coefficient of determination is one of your best indicators of its performance. So 1.0 would actually be perfect result, so a 0.93 is actually really good. However, a lower coefficient of determination would not mean that the model is not a good model. It just means that for the data that was provided, it doesn't perform as well. The way you get the performance higher is to actually do retraining, which is what we will cover in the last section of this presentation. Next, we will create a web service. First, we'll run our automobile price experiment to ensure there's no errors, and then we will select Set Up Web Service, and we will select Predictive Web Service. An animation will show as Azure prepares the predictive experiment. We'll go ahead and run that predictive experiment to ensure there's no errors, and then we will select Deploy Web Service. We will select Deploy Web Service Classic version. Now let's see a demonstration of everything we've covered so far. In the Azure Studio website, we'll create a new experiment. We'll select Blank Experiment. The first thing we'll do is alter the title so that it will say Auto Experiment. Now we need to get the sample data. In the search box, we'll search for the automobile sample data. We'll then select the automobile price data module and drag and drop it to the design surface. After repositioning a little bit, we can right-click on the circle and select Visualize. You'll note that we have about 205 rows. If we scroll all the way to the right, we'll see the price column. We can select the price column, and in the Properties, after scrolling down, we can see the Compare To drop-down. We're going to select number of cylinders. This allows us to compare the price to the number of cylinders. This will show us a candlestick chart, and we see that there is a relation between price and number of cylinders. This tells us that number of cylinders is a good column to use for our predictive experiment. Let's also show how you can use an R script to manipulate the data. We'll search for and drag and drop a execute R script module to the design surface. We'll connect it to the automobile price data module. We can then alter and create our own R script. In this case, on line 6, you'll see that any row that has no data for column 2 will be eliminated. We'll then run the experiment. This will ensure there's no errors, as well as populate the data for all the modules. After this runs, we can right-click on the circle underneath the Execute R Script module and visualize the results. You'll now see that we only have 164 rows, and that is because any row that did not have normalized losses was eliminated. Now, we will select only the columns that we plan to use in our experiment. We will search for and drag and drop a Select columns and dataset module to the design surface. We'll connect it to the output of the execute R script. We will now select the columns that we plan to use in our experiment. We'll click the Launch Column Selector button, and we can search for columns that we plan to use. For example, we can search for the price column, select it, and it will be part of the experiment. Or we can clear the search box, which will show all the columns, and we can select the columns one by one. When done, we will again run the experiment to populate the Select Columns and Dataset module. We can then visualize the results in the module. We will see that we still have 164 rows of data. However, the only columns that we have will be the ones that we selected. Now we're ready to train our model. The first thing, however, is to drag and drop a split data module to the design surface. We will indicate that 70% of the data will be used to train the model. We'll of course run the experiment to make sure there's no errors, and also to populate the split data module with the data. Now previously we used the cheat sheet to determine what model we're going to use. However, before we can consume that, we have to search for and drag and drop a train model module to the design surface. We'll connect the leftmost node for split data to the train model module, and we'll search for the linear regression model that we chose and connect that also to the train model module. And we will then launch the column selector for the train model module, and we will indicate that price is the value that we are trying to predict. We'll then run the experiment to populate the data, and actually at this point we have a trained model. However, we still need to score the model and evaluate the results. So we're going to get a little space here, and we're going to search for a score model module, drag that to the design surface. One input will be the model, the other input will be the split data that we held back. Now when we run the experiment, the score model module will take the split data that was held back and run it through the model and see what the model would have predicted. So when we visualize the results and then we scroll all the way to the end, we see the actual price from the data, but we also see a new label, a new column called scored labels. This is what the model predicted the price to be. As you see, they look pretty close. However, we need to statistically evaluate those results. So to do that, we're going to search for and select an evaluate model module. We'll go ahead and drag and drop that to the design surface, and we will connect that to the score model module. Of course, as usual, we will run the experiment to populate the data. Then when we visualize the data, for a regression model, the coefficient of determination is the best indicator of the performance. In this case, we see that the coefficient of determination is 0.93. A perfect score would be 1.0. So this model is sufficient for our needs. We will now create a web service. We'll click the Setup Web Service button and select Predictive Web Service. An animation will run to show that it's removing all the modules that are not needed. We will also see that we're on the Predictive Experiment tab. We'll need to run the predictive experiment to ensure that there's no errors. And now we will deploy the web service. We'll click the Deploy Web Service button and we will select Classic Web Service. After the animation runs, we will be directed to the API configuration page for the web service. We will now operationalize. First, we will create and consume the web service using the Excel plugin. After we create the web service, we can click on the Configuration tab, which will allow us to enable sample data. We'll click Save and then click the button to return to the web services. This is where you can select your web services in the future. We'll go ahead and reselect the Auto Price Experiment web service that we just created. We can then, under the API Help page, under the Request Response section, select the Excel 2013 or later application. When Excel opens, you'll have to click the button to enable editing. The Azure Machine Learning plugin will display, and the Auto Price Experiment button will also display. Click the button to enable the experiment. Under the Input section, we can then click the Use Sample Data button. This will display sample data in the grid. We can select a section of the grid, and then under the Input section, click the Select Cells button, which will cause the Select Data pop-up to display. The cells that we selected will already be filled in, and we can click OK to confirm our selection. At this point, under the Output section, we simply indicate an open cell on the worksheet and click the Predict button, which will then call the web service. The model will be called and it will score the sample data. The model's results will be displayed under the Scored Labels section. Let's see a demonstration. We're back to the API page for the web service. If we click the Configuration tab and we scroll down a little bit, we can see that there's an option to enable sample data. This will help us with calling this web service from Excel. We'll go ahead and click Save to save our changes. Now, to show you how to get back to this page, if you click on the world icon there, that will take you to the web services page, and there we can see all of our web services. So let's go ahead and reselect the Auto Experiment web service, which takes us back to the page that we were just at. Now, under the API Help page section, under the Request Response part, we can click the button to say Excel 2013 or later. We'll get a warning that sample data will be enabled. We'll go ahead and click Save. This will allow us to save the Excel file to our local computer. We'll then click on it to open it up. Now, when Excel opens up, you're going to see a message to enable editing, and this is because there's a number of macros that have been embedded into the Excel file. The Azure Machine Learning plugin will load and it will connect to our Auto Experiment web service. We'll click the button to enable it, and then we'll click the button to use sample data. This will put sample data in our worksheet so that we don't have to type in all these values ourselves. Notice that price is still a value that is taken in, though the predictive web service doesn't actually use that price when doing a prediction. So we'll go ahead and highlight the fields and click the columns and cell selection button. Click OK to confirm our selection. In this case, we will not have headers, so we'll make sure we'll uncheck that box. And then we will indicate where we want the output to be. So we'll enter a free cell here, and we then just click the Predict button. Now our actual web service will be called and the prediction will come back. So when we scroll to the right, the Scored Labels column is the predicted result, and as we see, it's pretty good and it's quite close. We will now consume the web service in an ASP.NET website. We will create an ASP.NET Angular website, which will allow us to price the vehicle. We'll be able to fill in the fields, click the Price Vehicle button. This will call our web service, and the predicted price will display. We'll also be able to record an actual price. This will allow us to export all of the recorded prices to use for retraining, which will be shown in the last part of this presentation. First, Part 1. Create an ASP.NET Core application. First, we'll select the Web Services icon and select our Auto Price experiment. On the configuration page, we'll be able to click the button to copy the API key. We'll save this because we'll need it later. Under the API help page, we'll click the request response link to take us to the API help page, which will show us the post method that we'll need to use to call the web service. We'll select that and copy it. We'll need it later. If we scroll down the page, under sample code, we'll see some sample code that we can also use to call the web service. We'll also copy this code because we'll need it later. Now we'll create the ASP.NET web application. So we'll go to our hard drive and we'll create a directory, type cmd, that will drop us to the command line, and we'll type in the line that you see on the screen. This will install the Microsoft ASP.NET Core SPA templates. After the templates are installed, the help screen will display, and then we can type in .NET New Angular to create an Angular ASP.NET Core application. The application will be created, and we can then double-click on the CS project file to open the application in Visual Studio 2017 or higher. We can then select Debug, Start Without Debugging, and our web browser will open, and we'll see the default template displayed. Now, Part 2, we'll create an ASP.NET Core application. First, we're going to install PrimeNG, which are open source free components that will allow us to easily create a UI. We'll open up the package.json file and enter the commands to enable PrimeNG and also its dependency, which is FontAwesome. We'll then open the webpack config vendor file and add the files that PrimeNG needs, as well as FontAwesome. PrimeNG also requires us to add support for GIF, so that we'll put that in the rules in the webpack configuration. We'll also alter the index.cs HTML file to simply have the app tag just load without trying to enable pre-rendering, which PrimeNG does not currently support. We'll also change the index, the layout CS HTML file so that it takes out the sampled display that you saw earlier, so that we now have a simpler display. Because we altered the webpack config vendor file, we'll have to drop into the command line and recompile it. Now we'll enable scaffolding, so we right-click on the project file in Visual Studio, select Add New Scaffolded Item, and select Full Dependencies. This will install scaffolding. A help page will display indicating that we need to right-click on the project, select Edit the CS project file, and add a line to support code generation tools. We'll then create a database by selecting Tools, Connect to Database, and we'll enter a name for a database. This hasn't been created yet. When we click OK, it'll ask us to create the database, and of course we'll say yes. After this, we're going to add a new table. This table will allow us to store the values for the predictions we'll make, and so we'll call this table Vehicles. We'll enter the SQL schema and click Update Database, and the database table will be added to the database. Now we need to enable Entity Framework, so we'll right-click on the project, select Manage NuGet Packages, search for the Microsoft Entity Framework Core Tools. We'll go ahead and install that. Next, we'll go into the NuGet Package Manager console, and we'll enter a line which will create scaffolding. We'll point the scaffolding to the database table that we created, and it will create a data context in our models folder. Because we're using ASP.NET Core that supports and actually requires dependency injection, we'll remove the onConfiguring section and replace it with a constructor that will allow for dependency injection. Now, to implement dependency injection, we'll go into the startup file, first add some using statements, and then under the configure services section we will add a section that will enable the data context that we just created and point to a connection string that we're going to call Azure ML Database. We'll then go into the app settings file and actually put in that connection string. This connection string is pointing to the database file that we created earlier. Next, create ASP.NET Core Application Part 3. We'll create a class file that will store our settings that we're going to need to call our web service. So we'll create a class called Azure ML Settings with two properties, primary key and base address. We'll then return to the startup file, and again, as we did before with the add data DB context, we will configure a section that will for our Azure ML settings, pointing to a connection string that we're going to call Azure ML Settings. We'll then go to the app settings file, and we're going to put the primary key and base address that we got earlier from the help pages in the Studio website that we copied earlier. We'll then create a class called Azure ML Parameter, which are values that we will use to pass from the ASP.NET website into the Angular server-side code. Now we're going to create a controller that will talk to the Angular code, and also this controller will be the code that actually calls the web service. This shows you what that code looks like. Primarily at the top, it gets the Azure ML settings that we need to talk to the web service, and then it calls the web service. There's a method. The method that actually calls a web service is the code that we copied earlier from the API web page in the Azure Studio website. Now, part 4 of create an ASP.NET Core application. We're now ready to create the Angular part of the application. So in the client app folder, we'll clear out all the previous content in the app folder. We'll first create our app module file, which we will register all the components that we'll need for our application. We'll then create an app component file. This will be the first file that will run for the application. Then we're going to create a price vehicle folder. This is where we're going to put the code for our current application. We'll create an Azure ML Parameter class, which will exactly resemble the C# class that we created earlier. This is how Angular is able to communicate with the server-side ASP.NET Core code. We'll then create a service that will use the parameter class to talk to the ASP.NET server-side code, and you see that we have two methods here, a price vehicle method and a record price method. We'll then create a HTML component file. This is where we'll have the markup for our application. The markup is actually quite long. This is just showing you what the top part of the section looks like. We'll then create the TS code behind file. This is where we have the code for our application. This first screen here is showing you the entry part of that code, and then lower down you'll see we have a price vehicle method and a record price method. These methods call the service that we created a few steps ago. We can then select debug, start without debugging, and the application runs, and we can price a vehicle, record a price, and export the data. Let's see a demonstration. Let's look at the Angular application. We'll first open this up in Visual Studio, and we'll take a look at all the files that it contains. We'll then run the application, which will open it up in our web browser. We'll then see the UI to price vehicle. The price vehicle button will give us the predicted price based on the values selected. Let's go ahead and change some values. For example, we'll change the make, we'll change the fuel type, and we'll change the engine size. When we click the price vehicle button, we see we get a different price. We can also record the actual prices that the vehicle sold for by simply entering the price and clicking the record price button. We'll get a confirmation of that. When we click the export data button, we will see all the recorded prices that we saved. We can then use this data for the retraining. We will now retrain the model with new data. This is where we're going. If we look at the first row, the top row, we currently have an auto price experiment where we created an auto price predictive experiment. We then created a predictive web service which currently has a single endpoint. Where we're going is that predictive experiment web service will have a second endpoint. This is the endpoint that the Excel application and the Angular application will then be pointed to. The Angular application will continue to supply data, and this data will be consumed by a new training web service which will be connected to the original auto price experiment. This training web service will create an iLearner file which will then be patched into the second endpoint that we will create. Here's an overview of the retraining process. First, we prepare our retraining data. We do this using the data from the automobile Angular 2 application that we created earlier. We then create a new iLearner file, and then we use that to patch into the new endpoint that we create on the predictive web service. Here is where we are now. We currently have an auto price experiment, which from there we created an auto price predictive experiment. We then created a predictive web service, and our Excel application and our Angular application are currently pointed to the first endpoint. So this is where we are right now. The Angular application allows us to record actual prices for the vehicles. We can then click the Export Data button, which will create an Excel spreadsheet of the recorded prices. When you're doing retraining, you need to do the retraining as a single batch process with all your data. So we need to get the original data that we use to train our model. So we'll return to the Azure Machine Learning Studio, click on the Experiments button, and select the original auto price experiment. The auto price data module allows us to download that data. We will then take that data plus the data that we gathered from the Angular application. We'll put that into a single CSV file, and we'll go ahead and save that. We'll need this file later. For the retraining process, we'll use an Azure storage account to upload our data to and to hold the updated iLearner file. So we'll go to portal.azure.com and create a storage account. To interact with the storage account, we'll download the free Windows Microsoft Azure Storage Explorer. We'll go ahead and open up the Azure Storage Explorer, select our Azure account, sign in, and we'll create a blob container on the new storage account that we created. This blob container will be called experiment output. Now we'll need some values so that we can interact with this programmatically. So the storage container name that we just created is called experiment output. However, the storage account that it is in is an account we created earlier in the portal.azure site. In this case, we called it AI Help Website Storage. So we'll need both those values. Under the properties for the storage account, we can get the storage account name and the storage account key. So these are all the values we will need to programmatically interact with this. So again, here's an overview of where we are now and where we're going. So at the bottom, we're going to show how we're going to add a training web service to the auto price experiment, and this will produce the iLearner file that we will then later use to create a new endpoint on the predictive web service. We will return to the experiment and we will select the original auto price experiment. Now we're going to need to add some input and outputs to this experiment. This will allow us to input data and then to receive the iLearner file. We're also going to add a second output that will allow us to see how well the model scored against the new data. So we will search for and select an input, and we will add that module to the workspace, and we'll connect it to the execute R scripts module. We're doing this because this input is bypassing that original automobile price data that we used to originally train the model. We will then add two outputs. One is to the train model. This is the iLearner file that we will need for the retraining, the result of the retraining. But then we're also going to add an output to the evaluate model. This will produce a CSV file which will contain the contents of the evaluate model, which will allow us to see what the coefficient of determination is. We'll go ahead and save this as a new experiment, and we're going to call this the training experiment. We'll go ahead and run it to make sure there's no errors, and then we will click the button to set up a web service, and we will select classic web service. We'll go ahead and select the web services icon, and then we'll go ahead and select this web service that we just created, and we'll copy the API key. We're going to need that to programmatically interact with it. However, instead of selecting the request response as we have done in the past, we're going to select the batch execution link. When doing retraining, you always do it as a batch execution. This will take us to the API help page, which will provide sample data, and we'll go ahead and copy sample code, and we'll go ahead and copy that sample code. We'll need it later. Now we're going to create a batch retraining program. We're going to open up Visual Studio 2017, create a new project, and we're going to create a new console application. We're going to take the code that we just copied earlier, paste that in. There will be in the comments some directions for some additional packages we'll need to install to support that code. And then we will take all the values that we had earlier, and we will replace the default values with those values. The last value that you see at the bottom, upload file to blob, this is the CSV file that we created at the first step, where we took the original sample data that we used to train the model with the data that we captured from the Angular application. So you see that that's pointing to our hard drive. When this program runs, it will upload that file to the Azure storage, run the processes, and create the iLearner file, as well as the file that will indicate how well the model performed. We'll go into properties and set as a startup object the code that we just pasted in. We'll go ahead and build. If you see any build errors, for example, the upload from file has a file open parameter that is no longer needed, so you can go ahead and just remove that, and then the code should build just fine. So we'll go ahead and select debug, start without debugging, and it'll take about 15 minutes, and the program will run. When it's done, you'll see that there's certain values. Let me go back to this. You'll see that there's certain values that if this were a fully automated process, these values can be retrieved to further to use in further processing. However, in this case, we want to go ahead and open up the Azure Storage Explorer so you can see what happened. What happened was 3 files were created. The first file, input1 data blob CSV, that's the file that's actually from our hard drive, and this was uploaded to Azure Storage. The second file, output1 results.ilearner, this is the new iLearner file. This is the new model, the updated model. This is what we will use to patch into our web service to create the endpoint 2. And finally, we have the output2 results.csv file. This is the file that allows us to see how the model performed. If we open up this file, we'll see that the coefficient of determination is now 0.81. This actually isn't that bad. It's sufficient for our needs. However, the main reason why the value is lower than it was before is that the new data that we have does not perform that well. The model does not perform that well against this new data. The way we can improve that is to gather yet more data. We'll turn back to the results in the console so that you can see that these are the values that we would need for further processing. It tells us where the iLearner file is, and it provides the base location of the iLearner file, and more importantly provides the SAS blob token for that file. This is needed so that because there's security to get to that file, so you'll need the SAS blob token as well as the base location and relative location to get to the file. This SAS blob token will actually expire after about an hour or so. So for further processing, if you use the token immediately, it's fine. However, if you need to get a new token, we can return to the Azure Storage Explorer, select the iLearner file, and right-click on it and select Get Shared Access Signature. Go ahead and click Create, and we can also get a new fresh SAS blob token as well as the base location and the relative location, which will of course be in 2 parts. So now we're ready to patch first create a new endpoint and then patch that endpoint with the new iLearner file. We'll return to the studio, select Web Services, and this time we're selecting the predictive experiment, the web service that we created from the predictive experiment. We're going to scroll down to the bottom there to manage endpoints, and we're going to click the new button because we're going to add a new endpoint to that web service. We're going to call that new endpoint Retrained. It will show up. We'll then select it. We'll then select the Consume tab, and we will get the primary key that we'll use to access this new endpoint. This is both for consuming the endpoint as well as to patch the endpoint with the new iLearner file, which is what we're going to show next. We can also get the URL to call that web service, that new web service endpoint. Now to patch the web service, we can click the API help button, and we can scroll down to the update resource section or the patch section, click the link to select the sample code, and we can copy sample code that will patch that endpoint with the new iLearner file. We'll go into Visual Studio and we will create a new console application using the sample code that we just copied, and here we have to put in the API key, the base location, relative location, and SAS blob token of the iLearner file. We'll then run that program and it will then patch that endpoint. Finally, we will consume that new endpoint. So we'll return to the original Angular application and we will update the primary key and base address of the new endpoint. The thing that you want to be careful for, though, is that the new endpoint, we'll put format swagger at the very end of the endpoint, and you want to go ahead and change that to details equal true. After that, when you run the Angular application, it will then consume the new endpoint with the updated model. Let's see a demonstration. Back at the Studio Azure website, we're going to select our initial training experiment. So we'll ensure that we're on the training experiment. I'm going to zoom in a little bit and reposition. And we're going to select the automobile price data raw module, and we're going to download that data. So it downloads as a CSV file that we can open up in Excel. Now we're doing this so that we can get to all the original data that we had. We are now going to take the data that we gathered from the Angular application, and we're going to go ahead and select all of that, and we're going to copy that, and we're going to paste that to the bottom of the original data. When retraining the model, you have to retrain it with all the data. Something to keep in mind for pricing: when we use this data to retrain the model, we will actually invoke a transaction for every single row. So here we have nearly 300 rows. That'll be 300 transactions. Now we need to create an Azure storage account. So we'll go to portal.azure.com. We'll search for and select storage, and then select storage account. After selecting this, we'll have to fill in a couple of fields. The first indicating what we will want to name our storage account. We'll then fill in the other fields, including selecting or creating a resource group, and then we'll go ahead and click the Create button. Now, to interact with the storage account, we'll go to storageexplorer.com and download the free Microsoft Windows Storage Explorer. So we'll open up the Microsoft Azure Storage Explorer, and we'll sign in using our Azure account. After signing in, we'll go ahead and create a blob container. We're going to create a container called experiment output. Now we're going to return back to the Studio Azure ML.NET site, and we're going to select the original training experiment. Now what we're going to do here is we're going to add a web service input and two web service outputs. The input we're adding is so that we can provide data that we will upload to Azure Storage to this web service as its input, so that it can train the model using this new data. We will then search for the web output module, and we will add two web service output modules to this experiment. And the reason why we're doing that is the first one we're going to connect to the train model module. This web service output will then contain the iLearner file, and this is what we'll use to patch into the new endpoint that we will create on the predictive web service. We will also have a web service output that we will connect to the evaluate model. This will contain a CSV file that will show us what the coefficient of determination is. So we're going to go ahead and make a copy of this and save it. We'll go ahead and run it, and that's to ensure that there's no errors. And then as the final step, after it finishes validating, is we'll click the button to set up web service, and we will select deploy classic web service. So now we have a web service that we can use to retrain the model. We will select the web services page and select the web service that we just created. on the API configuration of the page, we'll see the API key. We'll click the button to copy the API key because we'll need it later. We'll then select the batch execution link because when retraining a model, you'll always use a batch execution. This will take us to a page that provides sample code. We will then copy the sample code and we will then go to Visual Studio. Inside Visual Studio, we'll select New Project and we will create a new console application. We'll call this application Batch Retraining. We will then take the sample code that we copied earlier and we will paste it in. Now we will have a number of build issues that we have to resolve. The first of which is to install the NuGet package for the Microsoft ASP.NET Web API client. So we can just go ahead and copy this line, select the NuGet Package Manager console. After it initializes, we'll go ahead and paste the line in, press return, and the NuGet package and all its dependencies will be installed. After they're installed, a lot of our build errors will go away. However, we see that Windows Azure Storage is still required. So if we carefully select Windows Azure Storage and we use install package, we press return, the NuGet packages will be installed and those build errors will go away. We'll see that we will still have one more build issue that we have to resolve, and that is the sample code at the time of this presentation includes an error, and that is that the upload from file method doesn't need the file .open parameter. So we'll go ahead and remove that. We'll then paste in the storage account keys and settings that point to our Azure storage and our web service, and then we'll change the startup object so that it will start up the sample code that we have pasted in and fixed, and then we'll run the program. It'll take a couple of minutes for this to finish running because it's uploading our sample data to the Azure storage, and then it's retraining the model, and we get back all the values that we need for the next step, which is to patch the new endpoint that we'll create on the predictive web service. So at this point we can go ahead and just copy these for later use. However, let's go over to the Azure Storage Explorer to see what actually happened. 3 files were created. The input file was the one that was uploaded that we had created earlier, and the output to results.csv, when we open that, it allows us to see what the coefficient of determination is, which tells us how well this model performed against the retrained data. We see that the value has dropped down to 0.80. It's still sufficient for our purposes. However, if we wanted a better performance, we would need to have more data that was of the type that was similar to the data that we just used for the retraining. If our access signature expires, it's showing you here how you can get a new one through Azure Storage Explorer by right-clicking, selecting access signature, and then copying the URL and query string values. Now let's return to the Studio website and select the predictive experiment. So the predictive experiment is the one that we're actually using to do our predictions. Let's go over to the web services page and let's select the web service for the predictive experiment. Now we're going to add a new endpoint. The reason why we need a new endpoint is we cannot use the original endpoint because it's hard-coded to the training experiment. So we'll select Manage Endpoints. We'll select the New button to create a new endpoint. We'll give the new endpoint a name of Retrained. We'll go ahead and click Save. So now we have a new endpoint. We now need to patch the new iLearner file to this endpoint. So we'll go ahead and select the endpoint, and under the Consume tab we will see the primary key that we will need to access this new endpoint. And also, if we scroll down, we'll see a patch section, and we'll click a button that will take us to sample code that we can use to patch the endpoint with the new iLearner file. All the resources, files, walkthroughs, and forums are available on the AIHelpWebsite.com. Thank you.